In this section, we're looking at the derivative as rates of change. First problem. How fast is the area of a circle changing with respect to its radius when the radius is equal to 4 millimeters, 4 meters actually. So we need the formula for a circle. So the area is pi times the radius squared. So how fast is the area changing? So we're looking at the change in area with respect to the radius over the change in the radius. And so therefore, we're actually going to find dA dr. So we need to take the derivative of the area with respect to the radius. So therefore, we get dA dr is equal to pi, and then I'm going to get 2r. So that's 2 pi r. And at the exact moment that the radius is equal to 4 meters, then that means dA dr is going to be 2 pi times 4. We get 8 pi. Okay. Next problem, we're going to look at free-falling objects. And with these free-falling objects, the problem that we're going to solve, we're going to have a ball is thrown up, which eventually falls down. Okay, the launch velocity is 160 feet per second. And it reaches a height of s of t equal to 160t minus 16t squared feet after t seconds. Okay, so the first question is, how high does the ball go? Well, in order to figure out how high the ball goes, we have to look at when the velocity of the ball actually goes to 0. So if the ball is traveling up, hits a velocity of 0, and then speeds up as it comes back down, at this point right here, the velocity of the ball is 0. So in order to find the velocity, we take the derivative of the displacement, and then we're going to set that velocity equal to 0. And when we solve this, we get t is 160 divided by 32. So that's 5 seconds. So the ball, we know now at t equals 5 seconds is when it turns around and comes back down. So now we need to find the displacement at that point. So what is the displacement? When t equals 5. So we're going to put that into s, and we get s of 5 is equal to 160 times 5 minus 16 times 5 squared. That gives us 800 minus 400, which equals 400 feet. So the ball goes 400 feet high. Okay, second question is, what is its acceleration? At time t? Well, we know that velocity is a derivative of position and acceleration is a derivative of velocity. So therefore, we're going to get that acceleration is the derivative of velocity, but that's just a derivative with respect to t, and our velocity was 160 minus 32t. So that's minus 32, and that has units feet per second squared. So that is the acceleration. Okay, what is the velocity and the speed of the ball when it is 256 feet above ground? Okay, so if we go back to our picture, and we're going to take this as the ground. So at some point, we already know that this is 400 feet because that was how high it got. But at some point in here, the height is 256 feet. So we need to find out when that occurs. So now we want S of t to be 256. So that is, we let 160t minus 16t squared to equal 256. So if we put it all on one side, we get 16t squared minus 160t plus 256 is equal to 0. Let's factor out 16. That leaves us t squared minus 10t plus 16 is equal to 0. And this factors. We can divide out the 16. So this factors and becomes t minus 2 times t minus 8 is equal to 0. So we can say that the ball is exactly 256 feet when t is 2, that's on its way up, and t is 8, that's on its way down. And the question was, what is the velocity at those two times? Well, the velocity, if you remember, v of t is 160 minus 32t. So v at 2 is going to be 160 minus 32 times 2. And this is 96 feet per second. And then v at 8 is going to be 160 minus 32 times 8. And that turns out to be minus 96 feet per second. So this is the velocity on the way up. And this is the velocity on the way down. When the height of the ball is 256 feet in the air, and the speed, well, the speed we write as nu. It's the absolute value. And for both of them, it just turns out to be 96. Last question is, when does the rock hit the ground? Well, let's go back to our picture. If the rock hits the ground, then its displacement is 0 again. So we need to solve s of t is equal to 0. So we're going to get 160t minus 16t squared is equal to 0. We're going to factor out 16t, and we're going to get 10 minus t is equal to 0. So t equals 0, t equals 10. So it starts on the ground, it's launched at t equals 0, it goes up to 256 feet, then it continues until it gets to the height of 400, where it turns around, comes back down, and it falls on the ground at t equal to 0. And that's the end of that problem. So now we have another problem. That is, we're going to let q of t be 200 times 30 minus t squared be the number of gallons of brine in a tank after the tank starts to drain. So we want to find How fast is the water running out of the tank at the end and at 10 minutes? So how fast is the brine running out of the tank after 10 minutes? After 10 minutes. Okay, so the rate of change of Q with respect to T is synonymous with how fast it's draining. So we need to find dq dt. Okay, so Q is a product of two functions. We can write it as 200 times 30 minus t times 30 minus t. And so now we want to find dq dt. So we're going to take out the 200 because that's not going to affect us. So now we're going to get the first 30 minus t times the derivative of the second is minus 1 plus the second 30 minus t times the derivative of the first is minus 1. So now we're just going to get 200, and here we're going to get minus 2 times 30 minus t. So now we get dq dt is equal to minus 430 minus t. So therefore, Q prime at 10 is going to be minus 400 times 30 minus 10, which turns out to be minus 8,000 gallons per minute. So here's a question from before. What is the average rate of change of Q over the first 10 minutes? Okay, so Q average is going to be Q at 10 minus Q at 0 divided by 10 minus 0. So we need to find Q at 10, so Q average. So Q at 10 is 200, and then we're going to get times 20 squared. And Q at 0 is 200 times 30 squared, all divided by 10. So let's simplify this. So we're going to get 200 times 400 minus 200 times 900 divided by 10. And this answer comes out to be minus 10,000 gallons per minute.